Hi, I'm Bob Vila. Welcome home again. Lots to show you today. We've made great progress with the demolition in here, and today we're kind of shoring up some of the second floor areas so that we can put in a new beam that's going to give us a huge, beautiful front room. We're going to take you to Vancouver, British Columbia, where they manufacture these beams that we're using here, and we're also going to be busy digging some holes in the front yard and replacing our water service with a nice new copper pipe. So stay with me. It's good to have you home again.
Sears presents Home Again with Bob Vila.
Whoa!
Hey,
You've
Bob.
taken down all the plaster in here, huh?
Yeah, how you doing today?
Good. How are you, Ron?
Good.
Well, this is nice to see. You've got a real big step taken here in terms of stripping our walls.
Yeah, we have this whole bearing wall stripped down. We have some of the partition walls down.
Yeah.
We have the bathroom gutted.
And eventually we will be removing all of this structural wall from here to here, right?
Right.
And replacing it with a big beam going across there. Boy, that's nice. We're going to end up with some wonderful big space in here.
Yeah, this would be a real nice room here. I don't know how we're going to use it yet, but...
Well, living dining room.
You know,
I mean, the whole thing will be about 30 by 20. Not bad. And then, what have we done here?
Well, we took out this old cabinet that was here.
Oh, that's right.
Okay.
The hutch.
Right. The
No,
old hutch. And,
No pennies, or did somebody already find them?
no pennies and no gold coins yet today, but you never can tell.
So this will allow us to kind of cheat the bathroom wall out this way and
Right.
still have a corridor here.
Right.
And then the bathroom will be that much bigger.
Right. We'll get a linen closet in there, and it'll be real
Guy,
nice.
what a disaster.
Okay. This is just one of your finest bathrooms, as you can see here.
Well, this is 90-year-old space, and at least we've got good solid cast iron in the wall, which is a vent stack that I hope we'll be able to reuse.
Yeah, I think we can use all the vents and the main drains here, and that'll save us a lot of money. And
But the distribution will be replaced with
right.
new
all
piping.
all new copper
Yeah,
risers.
exactly. And this is how they created the wet wall here. They added this furring strip in front of the full-dimensional 2x4 so that they had, you know, enough depth to keep a hubbed
Right.
cast iron pipe in there.
Right.
Maybe we ought to replace the window,
Yeah,
too.
I think you're right. You know, maybe we'll either do glass block or something. I don't know. And this is the old kitchen.
Right, which is about 12 by 14, and the architect's plan calls for creating a large master bedroom here that incorporates the back porch.
Which I think this is going to be super. Have a nice little dressing area back here, and
Yeah.
some
Closet
closet
up against
space,
that wall.
some windows overhead.
I'm glad they took out this window. It's amazing how big the window is, the window opening, and yet when the window was in place, it was so grungy it didn't seem, you know, it seemed like a large opening. There's the header, the lintel.
Right.
This piece of wood is probably a good 6 inches deep, and it looks like it's 6 inches, and it goes all the way across there, bearing the load from up above, the load of the rest of the masonry back wall. And our plan is to remove the whole section of masonry wall so that we can open this all up.
Yeah, we'll have to go to our local junkyard and find ourselves a real nice steel beam and save ourselves some money.
At the salvage yard, yeah.
Salvage, yeah.
But it's still going to be a big job to get that steel in place, Ron.
I agree.
Boy, we lost a few partitions. What about
Yeah.
this?
These are our old hot water radiators. Did a great job when you had a small little bedroom right here, but now that we're opening this whole space up, I think we'll have to replace these with some cast iron baseboard heaters in here.
It's still in good shape, though. This could be used elsewhere.
It could be, but probably not in this house here.
No. Well, these rooms were so tiny. This was a little closet, another little closet, what they called a bedroom, which was literally two
Right.
steps up to this wall here. And then this was a deep pantry that gave off the kitchen. And now we've removed these walls, and we've created a space that's only about 8 or 9 feet wide, but it's 25 feet from one end to the other.
Yeah, this is going to be it'll be a real nice galley kitchen, and
Yeah.
we'll have a nice eating area over there. And
Yeah.
You'll exit out through that wall
And
over
the
there.
10-foot ceiling height really is going to make for some dramatic spaces. Then you still have one of these 1930s remodeling arches in the way here. That's coming out, right?
That's coming out.
Yeah.
And
You know, I've never really seen this stuff.
this is just metal beading that was able to be shaped into the arch and plastered over it.
Yeah.
And
You don't.
we don't need it. And then here we have some old BX. And I think that we can save a lot of this stuff, Bob. Looks like it's in good shape.
That armor-clad wiring is very safe. It hasn't been hurt by the demolition or anything.
We'll replace the switch, and of course with the receptacles.
No, you can't keep these.
We can't use these, and we'll have to turn those into new grounded receptacles.
Sure.
But we're going to save everything we can.
Yeah.
Okay.
What about on the second floor, the other flat? Have you done any demolition up there yet?
Well, we don't have as much work up there. We have a wall that's similar in scope to this that we're going to have to demo. We're going to do that later.
Yes.
The rest of the apartment is just cosmetic work.
Yeah. But at this point, we're pretty much ready to start shoring things up here for the removal of this wall.
Right.
And the eventual installation of a new beam up there, right?
We're ready.
And we'll carry the load with what's known as a Parallam beam. This is made out of wood. It's a man-made beam, what they call an engineered beam, because it can really carry a lot of weight. I just toured the factory out in Vancouver, British Columbia, where they're manufactured, with David Parker, general manager. First a couple of messages, then we'll be in Vancouver. Well, this is the most whimsical concoction we've seen in a while. Hi, David.
Hi, Bob.
How are you? What's the big idea here, hanging a sports car off of one of your beams?
Oh, we've just been showing off hanging the car from the beam and putting the beam on corrugated containers.
You mean you've got the weight of the car and the beam on these cardboard boxes?
That's right.
It's pretty impressive. You guys have some neat ideas around here. But what I want to know is how you make those beams.
Bob, we're all ready to show you at the plant.
Great. So what do we got here, Dave?
Well, we have the veneer from which we make our product. We can not only utilize this good veneer that you'd use in other processes, we can use what is considered waste. We call it fishtail. It comes because the log isn't perfectly round when we start the process.
Yeah, so this has been veneered off of around, is it Douglas fir?
That's right.
Yeah. Where's it grown?
In Oregon, Washington, and here in British Columbia.
So none of it is imported.
That's right.
And it looks like it just got veneered a week ago. What's the moisture content?
It's high. It's about 30 to 70% water in this pile right now.
So what's the first step in making your...
Our first step is right over here, and it's drying the veneer.
Okay. How do you actually dry it?
When we take the wet veneer and we put it right into these machines, it travels on these belts throughout a dryer blowing hot air at about 170 degrees Celsius on both sides.
How hot is that in Fahrenheit?
About 340 degrees.
And does it get all the moisture out of it?
Down to about 2 to 4%.
Fabulous.
When the veneer comes out of the dryer, we sense the moisture content, and if it's too wet, we mark it with a black paint and then put the veneer back through the dryer a second time.
Then what's the next step?
The next step is the veneer goes right into the stranders.
The stranders. So you're actually shredding that big sheet into strips.
What we're really doing is cutting them into large strips. The machine is like an old-fashioned real lawnmower that cuts them in these strips. The long ones give us strength. These short ones don't. We want to get rid of those.
So why do you switch direction here on the conveyor belt?
That's because we've got an ingenious device that the long ones have to jump this gap.
You've got a gap here. As long as you've got them on a diagonal, the long ones go through and the short ones fall in the...
That's right. Then they're ground up and they're used for energy to heat the dryers. We try and recycle the whole material in the plant.
Fabulous. So all of these will actually become a beam. What's the next step?
Resin is applied to the strand.
So what's actually happening within that mechanism?
This is our resin application system. It applies the resin and it dries the excess water off the strands, and then they come up the conveyors that you can see before.
What kind of a glue have you used for this resin?
This is a phenolic resin. It's the same as used in waterproof marine plywood. It's been around 50, 75 years.
Okay, and these are basically the only two ingredients, right?
That's it. That's
the wood and the glue. What's the deal with this conveyor belt below us?
This is a belt that has a conveyor that moves around in a circle, but at the same time the whole belt's moving back and forth.
Yeah.
And what it's doing for us is dropping those strands down into the top you can see on the right, so they're parallel and so they're well overlapped. Both the parallelism and good overlap are critical to the strength of our product.
So it's a linear overlap, and that is in strength and union. Yeah.
That's right.
And where are they going here?
Okay, what we have down here is a trough that by the time the trough is always moving towards our press.
Yeah.
At the same time, the mat is about 30 inches deep, and it's in the press, it's slowly compressed down to about 11 and a half.
30 inches down to 11 and a half.
That's right.
Wow, that's amazing. Okay, Dave, so what's going on here at these controls?
The total process line is controlled by this computer.
Yeah.
Density, moisture content, speed, the length of the beams that we cut off.
Right.
The whole thing is done right here.
Okay, and then what's the next step?
The curing, the pressing and the curing, the whole beam is cured by microwave energy, gets it over the boiling point of water, that solidifies the product and gets a good glue bond.
So that's over 212 degrees Fahrenheit.
Absolutely.
Great. And then what?
We have the pulling stations, which exert over 100 tons of pulling force that help pull the beam right out of the press. Without them, the press would jam shut and wouldn't work.
Of course, because of all that pressure that's being exerted there.
That's right.
Great. And what happens?
What we have next is a flying cutoff saw. This clamps onto the beam to the length we want, and then it comes right across with a blade and cuts it off to the length we want. Right now, the market's asking for 48 feet length, because the whole deck is full of 48-foot long beams.
But you could make them kind of, it seems, as long as you would want, right?
It's a continuous press, and we could theoretically, if we could handle them.
Yeah.
In reality, 66 feet is about as long as we produce under a normal
Yeah.
circumstances.
Then what's the next step after you've cut them to length?
The beam is then put through the sizer, which just cleans up the outside edges, makes sure it's perfectly square. Then if we want a smaller cross-section, it goes through a saw that cuts it down to a smaller cross-section, to a sander that sands all the sides. Then it goes through an intensive grading process to make sure there are no flaws in it. We wrap it, and we're all ready to send it out to the market.
It's packaged and it's ready to go into a building site. That's great. Tell you, what's amazing is the scale of everything is so huge here. How big are these Parallams that they're loading there?
These beams are 48 feet long. It's here where we wrap them, package them, put them on the trucks or the rail cars in the back, and they head to any market in North America.
All over the country.
That's right.
You know, there's one thing we haven't talked about, and that's the price point.
Well, in an application like yours, a structural remodeling, the one in Chicago, Parallam will save you money over the normal steel installation.
And they'll be easier to put in place.
That's right.
Can't wait to get ours. Thanks a lot for the tour, Dave.
Thank you, Bob.
It's been great. And we'll be back in Chicago in a minute after these messages. Now let's get together with Don McPoland, our plumbing contractor. We've got a new water service getting hooked up here. Hi.
Hi, Bob. How
How's
are you
it going?
today? Okay.
What's at the bottom of the pit here?
That's the old lead water service that was coming into the house that we have abandoned.
Mm-hmm.
We're installing a new 1.5-inch water service to upgrade the size for the purpose of water pressure.
So is that a requirement? When we remodel, we've got to put in a bigger water service?
Yeah, the city of Chicago grades the size of the service that is necessary for adequate water pressure.
Gotcha. And the old pipe is a lead pipe, which is a problem, right?
Correct. In an installation of a new water service, you do have a problem with contaminations of lead.
Yeah, I know what you're saying. They say that the old lead services, because you've got buildup of minerals on the inside of the pipe, are generally speaking safe. But you're just much better on with a new copper service, right?
Correct.
What have you got there? That huge pipe.
It's the gas main. It's the main gas service.
We don't want to fuss with that.
Correct.
So they've done very careful digging for us here, and actually dug right under the curbstone, I see. And is that the water main?
Yes, it is. That's the main water.
Okay, so how are they actually going to tap onto that thing without creating a geyser and flooding the street?
Well, they tap under pressure. They lower in the chain, which the barrel is attached to it, and they tap it directly under pressure.
Okay. Now that, what's the next piece you need? The barrel. Here you go.
Thank you.
And now the part of it that's actually going to be doing the drilling into the main is this thing here, huh?
Correct.
Pretty
Taps
sharp.
directly in underneath pressure,
Yeah.
and then they put a valve in.
Okay, so now you are secured onto that main. Are you ready for this piece?
Ready for this?
What do you call this?
The tapping bar.
The tapping bar with a drilling bit on the end of it. So Don, where do you get the power to drive that thing?
Power is right here. It comes from a truck and an air compressor.
They've got a compressor, and then this is simply going to... Whoa! There you go. So we have got one giant drill rigged up here, basically.
That's for certain.
Has he tapped it?
It's tapped now. Now we'll pull it apart and install a valve. Reverse it out.
Got it. All right, at this point, Don, all he's done is actually tapped a hole into the water main, and that bottom part, that bronze thing there, is actually keeping the pressure under control.
Right.
So what does he do in order to actually connect the copper pipe to the big main?
Well, he takes a valve, equals the pressure, and installs the valve, and then shuts the main
Is that
down.
it over here? Now this thing, okay, this is the next step then. He has to put that in, and this will actually be left behind, tapped into the water main.
Correct.
And our copper pipe then will get
Attached.
connected to this?
Correct.
I hear you. Well, there's a little bit of water coming out there. There. Ready for this one, guy? Yep. And this time we don't need the air compressor, we just use that wrench, huh?
Just use a ratchet wrench and you can screw that right in.
Done? Is he done?
Yeah. He's got a tap, so all he's got to do is pull the housing off.
The valve is in place.
And we can install.
There you go.
We have it.
Okay, so the next step then is to take the actual copper service pipe and tie it into that new bronze cup fitting there.
Right, Bob. You put on the Mitchell bend and flare the unit, tie it into the main.
So what is that stuff you're putting on there now, Don?
It's pipe dope. It's used as a lubricant so that the brass fittings do not cause friction and are easy to tighten.
Yeah.
Get a good seal.
And that's the final step in the operation here then, is tightening that up, right?
Correct.
So one last question, Don. What's that bend in the copper pipe left in there for?
Bend is a Mitchell bend. It's for the purpose of movement, so you don't snap the tap off.
So you've left a little slack in the line, basically.
Correct.
Good.
Correct.
All right, thanks for a great job. We've got a new water service, right?
Right.
Terrific. Let's go back inside and check with Ron. Stick around. We'll be right back after this message. Looks good, Ron.
Thanks, Bob.
Okay, so this is our temporary wall.
Right, this is the wall we're going to use so that we can take down our old bearing wall and put that new beam in.
And we'll be doing that next week, right?
Right.
But that's about a wrap for today. Come home again next week. We'll be putting in a beam here and a steel beam in the back of the house. We'll also be visiting a window factory in Iowa. Till next week, I'm Bob Vila. Gonna straighten it out here.